Welcome back. This is the second lesson recording for IM1, January 12th, 2021. So now we're up to card number 7 of Desmos. Information graph number 1. Looking at the graph, would you guess that it represents an arithmetic sequence, a geometric sequence, or neither? Well, it looks like the number, as the term number increases, 1, 2, 3, 4, 5. It looks like the value of the first term is something like, I don't know, maybe 55, and then going down to maybe somewhere between maybe 33 or something like that. It seems to be going down, but it does look like the distance is constant. Okay, so how much it's going down by seems pretty much the same. That means it's going down, but it's going down by the same amount. So that's arithmetic sequence. So I am going to say this is arithmetic sequence. In card number 8, it says, we expect the graph to represent the arithmetic sequence because we see the points to form a line. It's forming a line as if I was to connect these dots, it's going to form a straight line because we see points indicating a relationship that can change by the same amount each time. Looking at the graph, would you guess the common difference is positive or negative? It looks like the numbers are going down. That means you are adding a negative number or the common difference is negative. So the common difference will be negative here. It's positive, it's going to be negative. So I am going to say it's going to be negative. Okay, moving on. Card number 9. We expect the common difference to be negative because we see the points are decreasing. So that's just the information. Now finally, card number 10. Write the first 4 terms of the sequence represented by the graph. You can click on the points to display their coordinates. So if I click on it, I see 1, 57. This tells me the first term, a sub 1 is 57. That means the first term is 57. So I can write 50, I can type in here 57, comma. What is the second term? I can click on it. It gives me for when n is equal to 2, a sub n is 39. So I can write 39 here, comma, and then third term, when n is 3, a sub 3 is 21. And then for a is 4 or fourth term, a sub 4 is 4, I think was 3. And then finally for the last one, when a is 5, a sub 5 was negative 15. Okay, now what is the common difference? How are the numbers decreasing by? Okay, so to do that, I am going to go from pick one number, like the second number, and subtract the first. So it's going to be 39, take away 57. And what do I get? That's going to be 17 minus 9, that's going to be 8. And 5 minus 3 is 1. So I am going to go down by 18. So I am subtracting negative or adding negative 18 or subtracting 18. And to go from here, if I subtract 18 from here, do I get 21? Yes, I do. If I subtract another 18, do I get 3? Yes, I do. And that seems to be the constant. So what is the common difference? I figured out to be negative 18. Okay, let's summarize some of the key findings for sequence to graph. Okay, the x-axis represents the n or the position or the term number, and a of a sub n represents the y-axis or the value of the term, each term. Okay, so graph of a sequence are discrete, not continuous. What do we mean by discrete and not continuous? This is opposite of continuous. When something is continuous, we mean things are connected. So if I have a straight line joining it, then we will say it's continuous. However, it is the dots are separated. It's not continuous because you don't have any n. You can't have n to be 1.5. Okay? You cannot have 1.5 term, right? Or anywhere between the whole numbers. That is the reason that you have discrete or separated points, not connected points. That's what discrete means. That means it's not continuous or not connected. And so that will be a straight line connected. That will be continuous, but it is not continuous or connected. An arithmetic sequence follows a straight line pattern because each term changes by fixed amount. It's as if you can draw a straight line joining it, and just like we did before. Okay, like that line before. If I was to join those dots, it's going to form a straight line. Okay, and lastly, the increasing, the fixed amount it changes by, in that case, that's the common difference. Common difference would be positive if that line is increasing or it has a positive slope, or from going from left to right, it's the values are going up. So it's increasing. While as if you have common difference that is negative, that means the values are decreasing. So you would expect a negative slope if you were to just try to predict the pattern of the dots. And the common difference can be represented as how much is the y value changing or the a of n changing every time the x-axis value or the n is changing by 1. In this case, it's changing by 5. So in this case, common difference is 5. So with that, you are going to be working on card number 11 to 15 of Desmos. So please pause the video and work on that now. Okay, this is card number 11. So do you expect the sequence to be arithmetic, geometric, or neither? Okay, how can you tell from a graph whether it's going to be arithmetic or geometric or neither? For arithmetic, we said that you're going to have discrete points, that means separated points like this. But if you were trying to draw a line through those points, it will be a straight line. So it looks like it's the dots are forming a straight line, so it's going to be arithmetic. Okay, do you expect the common difference to be positive or negative? The a sub n, the values are going up. That means as the term number increases or the position increases, the values are going up. So the values are increasing, and therefore it's going to be positive. The common difference is positive because it's like you are adding some number to the previous term to get to the next term and to the next term and next term. Okay, so that's how much its common difference is, how much the y value or a sub n value is changing by. Okay, now it's asking you what is the common difference. Remember to click on the points to figure out the term value. If I click on this, I get 22. For when n is equal to 2, it becomes 34. So it goes from 22 to 34. So how much did the y value, y-axis value change by? It is going to be 34 take away 22, and that is 12. So the common difference is going to be 12. Do I need to check the others? Well, I could certainly do that. I have 34 here, plus 12 is going to be 46, plus 12 will be 58, plus 12 will be 70. Excuse me. All right, so the common difference, or D, is 12, positive 12. Okay, now for the sequence 5, comma 7, comma 9, comma 11. What is A sub 5? That means it's the fifth term. This is the first term, second term, third term, and fourth term. To figure out what the fifth term is, you need to figure out what the pattern is, right? Well, what's happening to the numbers? 5 is increased going to 7, and 7 to 9, 9 to 11. So how much is it being increasing by? It's increasing by 2, or you are adding 2 to the previous term. So that means we can do likewise. So you are increasing by 2. So we can add another 2 here because everywhere else has been increasing by 2. That leaves us with 11 plus 2 is going to be 13. So I know that A sub 5 is going to be 13. Okay, what about A sub 9? Okay, so A sub 9. So this was A sub 5. Okay, so we can figure out A sub 6, A sub 7, A sub 8, and A sub 9. That's the ninth term. So if I add another 2 to 13, I get 15, another 2, 17, another 2, 19, another 2, 21. So A sub 9 is going to be 21. Okay, and I'm going to submit. And then it asks you, okay, so what would you say if I asked you to find A sub 421? Are you going to keep finding it until 421st term? Hmm. Okay, you can click on any of them. No problem. I'll get back to you in 3 hours because that's going to take a while. Or I am crafty. I can get that to you in 1 minute. Okay, so how would I do that? Nope, I don't know how to do this. Okay, so I want you to reflect on how you feel about. Do you think you could figure out what A sub 421 is, or the 421st value of the sequence? Okay, so finding the nth term. For the sequence 5, 7, 9, 11, try to write an equation to represent the nth term. Your equation should start with A sub n is equal to, it uses the variable n. Okay, so let's think about it. This is A sub 1. This is A sub 2. And this is A sub 3. And 11 is A sub 4. Okay, so to get to the fourth term, I just kept on increasing by 2. So if I increase 1, 2, 3 times to get to A sub 4, increase 2, 3 times to get to A sub 4. Okay, so if I was to get to A sub n, I need to increase the common difference, which was 2. How many times did I increase? Well, I increased by 1, 2, 3 times when A for A sub n 4. But we don't want, so 3 times when n was 4. That means I don't want what n is, but I want n minus 1 times. Okay, so I'm going to increase to n minus 1 times. And then I am going to add that to in my initial term, which is the first term, A sub 1. Okay, and I'm going to explain that more during the lesson. Okay, final cut number 15. It gives you the equation as A sub n is equal to 2n plus 3. Okay, and that's what so you need to click one. Well, my equation that I came up with slightly different, but it does turn out to be the equivalent. See if you can process this. Okay, and then we're going to continue in the next recording.